This video will show you how to make a dynamic simulation on our robot, using the Dymola behavior modeling app. We will get into 4 parts. First, we will see how to set the imported kinematics behavior for dynamic simulation. Then, we will set the robot in a known position for the simulation. We will also see how to set a force at a given position on the robot. Finally, we will get the results of the simulation. Launch the Dymola app from a dashboard. Open the robot's assembly. In Dymola, create a new package called Dynamics. We will import the kinematics behavior from the robot's assembly like in the previous video on the kinematic simulation. Click on Generate from Kinematic. Select the robot's mechanism. Insert it in Dynamics. Name it KUKA Imported. Enable Update Mass and Inertia on parts before translation. Then, we will set the pivot connections for dynamic simulation. Drag and drop a spring damper from Mechanics, Rotational, component, near 1 on 2 pivot connections starting by the second one. Connect it as shown. Do it again 5 other times. Set them as the displayed values, C is the spring constant and D is the damping constant. The counting starts from the bottom. Then, we will set the other pivot connection. Set fixed start values phi to false in the initialization tab for one pivot connection on 2, starting with the first one. Let's create an interface for the tool. Drag and drop a frame A. Connect it as shown. The class can be pimped. The imported kinematic behavior is now ready. Now, let's add control to the robot's position. Create a new class. Name it Dynamic Simulation. Class type is Model. Insert it in Dynamics. Drag and drop KUKA Imported in it. In the tree, copy KUKA set pos core from Kinematics and paste it in Dynamics. This class was created in the Kinematics Tudo, but we will reuse it. Drag and drop it in Dynamic Simulation. Connect it as shown. The other pivot interface must not be controlled because they are already controlled by the spring damper behavior. For the input values, drag and drop a constant. Set it as a vector of size 6. Set it at the desired position. Connect it as shown. The constant will set the robot at a fixed position at the start of the simulation. The simulation can be made while the robot is moving. For that, give a variable value. For instance, the constant can be replaced by a ramp and the robot will move during the simulation. Now, let's apply a force to our system. The properties of the frame A are pointing to the center of mass of the tool. So if a force is applied directly on the frame A, the force will push on the center of mass. That's why we will translate the force from the center of mass to the drill. We will also rotate the local frame to control the direction of the force. To do that, let's go back to dynamic simulation. Drag and drop a fixed translation. A fixed rotation. An absolute sensor from Mechanics, multibody, sensors. A gain. A world force. A sine with variable frequency and amplitude feature. A ramp. Delete the extra blocks in case you have some. Connect the blocks as shown. In the sensors settings, enable Get A. Set the gain as a vector of size 3. Set the sine as a vector of size 3 and set use constant amplitude to true and use constant frequency to false because we will apply a frequency swept sinusoidal force. Set the ramp as a vector of size 3. An external force with a known point of application and a known direction is applied on the tool. The frequency of the force is a sweep between 1 and 150 Hz, thanks to the ramp. On the point of application, a sensor measures the acceleration. The gain normalizes the result with the magnitude of the force. Let's set some values to the blocks in order to control the simulation. 290 on X, 0 on Y and -85 on Z for the translation. For the rotation, set it to planar rotation sequence. Set the sequence to 1, 2, 3 and the angle to 90 on Y. Set the force to resolve in frame B. Set the sine amplitude to 4000 on X. Set the ramp's value to 150, the duration to 15 seconds and the start time to 5 seconds. Finally, set the gain to 1/4000th. Now, let's run the simulation. In simulation setup, set the stop time to 20 seconds as our force starts at 5 seconds and lasts 15 seconds. The Change Active View button allows you to move the blocks and see clearer the 3D simulation. Click on the play button to start the simulation. At 5 seconds, the force starts. In the simulation window, all data from the blocks placed before can be plotted. For instance, it is possible to see what is the fixed translation block. Here is how looks like the sinusoidal force. Here is the result expected, the acceleration on the point where the force is applied. Let's summarize what we have learnt during this video. First, we saw how to import a kinematics behavior and set it to be used for a dynamic simulation. Then, we saw how to set the robot in a desired position for the simulation. The third part was about applying a force on the robot with a known point of application and a known direction. Finally, we saw how to get the result of the simulation.